Hello everyone, welcome back. Next series, Introduction to the Debugging Challenges. Debugging is a valuable and unfortunately necessary tool for programmers. It follows the testing phase of checking if your code works as intended and discovering if it doesn't. Debugging is the process of finding exactly what isn't working and fixing it. After spending time creating a brilliant block of code, it is tough realizing it may have errors. These issues generally come in three forms: syntax errors that prevent a program from running, runtime errors that when code fails to execute or has unexpected behavior, semantic or logical errors when code doesn't do what it's meant to do. Modern code editor and experience can help identify syntax errors. Semantic and runtime errors are harder to find. They may cause your program to crash, make it run forever, or give incorrect output. Think of debugging as trying to understand why your code is behaving the way it is. Example of syntax error often detected by the code editor. For example, here we have misspelled function, and then there instead of curly braces we have given parenthesis. Function keyword is misspelled and there is missing parenthesis. It should be a right parenthesis and then curly braces, left curly braces should be there, which is missing. Here is an example of runtime error often detected while program executes. While true means it will run again and again because there is no case when it returns false, when it will be false, and while loop will stop. Calling loop starts an infinite loop which may crash your browser. Example of semantic error often detected after testing code output. In this case, function for calculating area of rectangle, but instead of asterisk for multiplication we are using plus for addition. So this is a logical error. Correct syntax and program executes, but this gives the wrong answer. Debugging is frustrating, but it helps to develop and follow a step-by-step approach to review your code. This means checking the intermediate values and type of values to see if they are what they should be. You can start with a simple process of elimination. For example, if a function A works and returns what it's supposed to, then function B may have the issue. Or start checking value in block of code from the middle to try to cut the search space in half. A problem in one spot indicates a bug in the first half of the code. If not, it's likely in the second. This section will cover a couple helpful tools to find bugs and some of the common forms they take. Fortunately, debugging is learnable skill that just requires a little patience and practice to master. So we will go to the first lesson in the next video. Till then, thank you for watching and see you in the next video. Bye bye.